Hello friends, myself R.D. Mahajan presenting my video on the topic Fourier series for odd function. Let us solve the problem. Find Fourier series for f of x is equals to x cube in the interval -1 less than or equal to x less than or equal to 1. Here the given function f of x is equal to x cube and the interval is -L to L type. Therefore we check whether the function is even or odd. Replacing x by minus x, we get minus x and its cube. Its value is x cube and -1 cube is -1. Therefore we get minus f of x, and therefore function is odd, is an odd function. And as it is an odd function, Fourier coefficient a0 is 0, an is 0, and bn is given by 2 by L integral from 0 to L f of x into sine of n pi x by L and its integration with respect to x. A substitute value of L as 1 here, it is -L2 plus L, therefore L becomes 1, therefore it is 2 by 1 integral from 0 to 1, 0 to L, f of x is x cube and sine of n pi x divided by 1 means we get sine of n pi x and its integration with respect to x. Performing integration by generalized part, x cube algebraic term, therefore we consider this as first one, and sine as trigonometric term, therefore we consider that as second one. Therefore integrating it by generalized part, we get bn is equals to 2 times first term as it is, integration of sine is minus cos n pi x by n pi, then minus derivative of x cube, its derivative is 3x square, integration of cos, next integration of cos, its integration is sine n pi x by n pi, and at previous n pi it become n square pi square. Next one is with minus sign, therefore plus derivative of 3x square, its derivative is 6x. Next integration of sine, is minus cos, and that minus sign it become plus cos of n pi x divided by n cube pi cube, then minus derivative of 6x, is 6, integration of cos is sine n pi x by n raised to 4 pi raised to 4. Next derivative of 6 is 0, therefore we stop here, and the limits from 0 to 1. When we substitute the upper limit, we get cos of n pi and sin n pi. The value of sin n pi is 0, cos n pi is -1 raised to n, and for the lower limit we get the terms sin 0 and cos 0. We have sin 0 as 0 and cos 0 as 1. All these standard values we get. Therefore it is Uh, when x is 1, 1 cube is 1, therefore 1. Cos of n pi, cos n pi is minus 1 raised to n divided by n pi. Minus minus it become plus. Sin n pi, as sin n pi is 0, that term becomes 0. Next is 6x. 6 into 1 we get 6. Cos of n pi once again minus 1 raised to n divided by n cube pi cube. And minus sin n pi, once again the sin n pi is 0, therefore that term becomes 0. Minus a lower limit, when x is 0, first term becomes 0 as x is 0. Next one becomes sin 0 is 0. Again x is 0 and sin 0, 0. All terms equals to 0. And then simplifying it, we get 2 and minus 1 raised to n we can take common. Here it is 6 by n cube pi cube. Minus 1 by n pi as the value of 0, an, bn in the Fourier series result we get. This is given by f of x is equal to a0 divided by 2 summation of an cos of n pi x by l. N changes from 1 to infinity, and summation of bn sin n pi x by l. N changes from 1 to infinity. Substituting the values of a0, an and bn. A0 is 0, an is also 0. The value of bn is 2 times minus 1 raised to n, 6 upon n cube pi cube minus 1 by n pi. Substituting that summation sign, 2 constant we take outside, therefore it is summation of minus 1 raised to n multiplied by 6 by n cube pi cube minus 1 upon n pi. N changes from 1 to infinity, sin of n pi x. And therefore the required Fourier series is, it is 2 times summation from 1 to infinity minus 1 raised to n multiplied by 6 by n cube pi cube minus 1 upon n pi into sin of n pi x as the required Fourier series. Containing sine terms only, as that function is an odd function. In my next video, I will discuss one more example for odd function. If you are watching my videos, please like and share it, as well as subscribe to my channel. Thank you very much.